Hello, I'm Jeremy Kirtley. Today we're going to talk about the fuel management system and the timing system. I've been in the industrial or the automotive and industrial field for about 31 years, working on everything from small cars to large pieces of land moving equipment. Today we're going to start with the air intake system. First, we're going to pull our air cleaner off. What we're working on here is a 4.3 liter V6 engine. Look here at our first part. Here's where the air comes into the engine. It goes through this filter. From this filter, up through the box I just took out, to our mass airflow sensor. Our mass airflow sensor, if there's ever any issues with it, most times we'll set a check engine light. When we look at it, we look to make sure all those little fins in there are clean and straight, because their purpose is to make sure the air that's flowing through here flows across the tiny wires inside this sensor. Those wires sense the amount of air coming from the front of the truck past the air filter into the system. From your mass airflow sensor on back should all go through this. All the air that comes into the engine should be coming through this. If not, it's unmeasured. When we look at our ductwork from our mass airflow sensor down to the throttle body, we notice we've got rubber and it flexes. Any of these little creases right here, as the vehicle gets older, can dry rot, crack. Our hose clamps can be loose and not sealing correctly. Any of that can let air into our system. We need to know the amount of air coming into the system because we want to know the amount of air to mix with fuel. The other thing we need to know, this is our air temperature sensor. We need our air temperature sensor because cold air is denser than hot air. There's more oxygen in cold air. So, like I said, we want to check and make sure we have no leaks from here down to the throttle body. We check the PCV valve hose. Any place there's plastic hose going into the intake, we need to check. It can crack, it can rot, it can suck air that's going into the engine that's not being measured by the mass airflow sensor. We get into the throttle body. When we take that off, we can see our throttle body. We see on this one that it's cable actuated. The cable is connected to your fuel or to your gas pedal inside the truck. When you pull that gas pedal, it pulls this cable. It opens and closes the butterfly here in the throttle body. Right now it would be set in idling. We have an idle control solenoid on the back side of here for whenever it's closed. Our idle control solenoid has a little valve right here that opens and closes to allow air in while it's idling. Whenever you push on the gas or the accelerator pedal, we move this throttle butterfly. As we move it, you can see how it opens. Our computer needs to know how that opens. So it uses another sensor over here on the opposite side of the throttle body. That is our throttle position sensor. Our throttle position sensor is just a resistor that goes across the board. It swings as our throttle swings. When it does that, it sends a different signal to our engine control module. Our engine control module then uses that information to make sure we have a good air to fuel mixture. our air to fuel mixture should be roughly 14.7 to 1. That's 14.7 parts oxygen to 1 part fuel. Whenever we burn that, most of what comes out the exhaust is just H2O, which is water vapor. As this thing runs and drives over the years, you can look down inside of it and you can see the black carbon that builds up along this butterfly. That can cause the butterfly to stick and make it hard for you to push the gas pedal down. It can build up where it doesn't allow the butterfly to close or open all the way. Those are all things that can cause this sensor to set a code and send a code to your ECM, which will turn the check engine light on. Our mass airflow sensor, it can get built up on here. Whenever it gets built up on there, it restricts airflow. When it gets built up on our wires in here, that doesn't allow our wires to read the amount of air that's coming through here correctly, which can turn on a check engine light. We go down a little further. This is our intake. This is where everything gets sucked down into here. We also have a sensor right here called a MAP sensor, which is manifold absolute pressure. It reads pressure and vacuum inside the intake. Our biggest issue there is also, again, it can have carbon buildup. It's got a little tube on it that sits down inside here. It reads the air pressure inside the intake or the vacuum inside the intake. Whenever you compress stuff, you have more oxygen in it. Whenever there's a vacuum, there's less oxygen. That's all stuff that our computer needs to know to make sure that we have the right air fuel mixture to go down into our cylinders. After we have the correct air fuel mixture, we've got our air measured, we've got our injectors down inside, which are going to shoot our fuel into the cylinders. Next, we're going to go to our timing system. Since it's a little bit of a pain to get to the crank sensor and the cam sensor on this vehicle, I don't think my cameraman wants to crawl down on the floor to get to our crank sensor, and I don't want to pull the distributor out of it to get to the cam sensor. We're going to show you a simplified version of it on a 4-cylinder. Your crank, which your pistons and rods ride on, that go up and down inside the compression cylinder that cause your compression. The crank shaft sensor reads each one of these teeth on the gear. The gear is attached to the crank. It has one notch in it that's a little wider than the rest. That notch will indicate to this sensor that the crank is on top dead center. Top dead center is the first place your computer wants to measure. It measures number 1 cylinder at the very top of the stroke, first stroke. This sensor is a magnet sensor. Every time one of these little teeth pass the magnet inside this sensor, it sends a signal back to your ECM. That's what tells your computer where your piston position is. It can calculate the 1 cylinder in the front. It can calculate 4 cylinders. It can calculate 8 cylinders. It can calculate 16 cylinders. All by the teeth on this bottom cam, or the bottom crankshaft. Next, we have a cam sensor, which works on the same principle. It's a magnetic pickup. Your cam will have teeth on that. Your cam shaft opens and closes your valves. Your valves are what allows the air and the fuel into the cylinder. It wants to know where the cylinder is. It wants to know where the cam is, because the cam lobes push your valves open. There's a certain point where it wants to open the intake valve. This right here is what tells the engine where it's at. That's what keeps this in time with this, especially on newer vehicles that adjust your cam timing. They're called cam phasers. And this can adjust to advance and retard the timing on the engine. And like I said, it's just a magnetic pickup that's going to read that information for us. All of this is all designed for our fuel to get down into our cylinder at the right time, at the right mixture. And if everything's working correctly, we have good power, we have good emissions, and that's, in a nutshell, your air fuel system and your timing system. Thank you for your time.